Hi students, hi everyone. 23 board exam, physics exam just got over. And now the preparations are on for 24 board exams. Many schools, I think they have started plus two portions. So I just want to discuss in an important numerical from first lesson, a frequently asked one. It is a book back exercise problem only, exercise 1.6. But what I'm going to do is first let me teach that book back exercise as such. Then next what I'm going to do is some changes I'm going to make, and we will try some other configurations also. Then what about the net force? So that way also we are going to try. Yes, first let us go to the book back problem as such. See, basically it is a square. At the corners of a square you have charges 2 microcoulomb minus 5 microcoulomb, and at C you have 2 again 2 microcoulomb, and at D again you have minus 5 microcoulomb. What is the question is, they are asking the force experienced by a charge that is 1 microcoulomb which is kept at the center of the square. So we just want to find what is the force experienced by this charge because of these four charges. See, basically how to approach this kind of problem is, first you have to see this 1 microcoulomb. What is the force experienced by this because of this 2 microcoulomb? First you have to see, you have to approach each charge at a time. So first you have to see for 2 microcoulomb what will happen, then minus 5 microcoulomb what will happen, then you have to go like that. See, 2 microcoulomb is at A, and at center also you have 1 microcoulomb. So both are basically positive charges. So by this time you would have learned, so you know very well, or otherwise like charges repel. So what will happen here, a repulsive force is experienced. This 1 microcoulomb will be repelled by 2 microcoulomb. So I have to draw an arrow like this. Fa, force due to the charge present at A, so will repel this 1 microcoulomb. So generally students will, repulsive force means they will think it should be the other way. See, we are testing it for 1 microcoulomb only. So whatever repulsion or attraction happens only for 1 microcoulomb. Okay, so we have seen what will happen for the charge at A. Yeah, similarly, now just look at the charge at B. So minus 5 microcoulomb. So what will happen? So this 1 microcoulomb will be attracted because it's a negative charge. So FB experiences an attractive force. Okay, now coming to charge at C. So again 2 microcoulomb positive charge. So which will again repel. So FC will be going in this direction. Now last coming to the charge at D, minus 5 microcoulomb. So unlike charges, so it will attract that 1 microcoulomb FD. So you are seeing the four forces. We have seen FA going like this, and FB going like this, FC going like this, and FD going like this. See, if you just look at FA and FC, so both the charges are same, 1 microcoulomb, 2 microcoulomb, FA and FC, and they are opposite in direction. So opposite in directions means they will nullify each other. So FA and FC will nullify each other. Similarly, if you look at the charges, that is this diagonal FB and FD, those two charges also same, minus 5 microcoulomb and 1 microcoulomb. Same on the other side also, the same charge system. FB and FD also, they will nullify each other. So if you see diagonal wise, so FA and FC, they nullify each other. FB and FD, they nullify each other. So the net force experienced by the charge 1 microcoulomb is 0. See, here I have written the formula. FA, it's K 1 by 4 pi epsilon. I have just written it as K. Q1 Q2 by R squared. So Q1 is 1 microcoulomb and Q2 is 2 microcoulomb. By distance is OA squared, half the diagonal square. Similarly for FC, again the same charge configuration, and OC again that's also half the diagonal only. So in magnitude wise, FA and FC are equal, and in directions, if you see, they are opposite in directions. That's why I have written here. So they nullify each other. See, similarly, I have written for FB and FD also. So K 1 microcoulomb and 5 you may see here I have not used the sign here. For vector quantities we need not use the sign. We are dealing that sign in the form of direction. So we have written here, we have shown the direction here attractive. So minus is taken in the form of direction, not as not as a sign. So that's an important input here. So similarly, for FD also 1 microcoulomb, 5 microcoulomb by OD. Anyhow, OB, OD are same. So they're same in magnitude, opposite in direction. So they nullify each other. So the net force acting on that 1 microcoulomb charge, which is at the middle, is 0. So net force is 0. So this is the textbook actual problem. See, now I have made some changes. See, I have changed the sign of the charge at C and charge at D. So now how to do this problem? What will be the answer? Let us discuss. In the exercise problem, see, I did not do the calculation also because net force is 0. Here definitely net force will not come 0. See, I have written for force A, K value, I have written charge values, I have written. So if the sides are 10 centimeter, diagonal will be 10 root 2. So by using Pythagoras, and what we need is half the diagonal, so 10 by root 2. So I have written the half diagonal value also square, and I have found out the answer. So 3.6 Newton along OC. This is force because of the charge at A. Similarly, now calculating force experienced by the charge at B. So negative charge, so basically which will attract this test charge of 1 microcoulomb, whatever charge kept at the center. So it will go along this direction FB, and I have written the magnitudes and 10 power 9 charge values are written, everything. So 9 Newton will be acting along OB. See, now is the interesting thing. Now let's come for the charge at C. So I have changed the sign here minus. So because minus, so it will attract 1 microcoulomb. So FC will also act in the same direction of FA. So FC also will act in the same direction of FA. In the previous exercise problem, this was plus 2, so the opposite, so they nullified. Here it will not nullify. So FC also will be acting along OC only. Again, magnitude wise it's equal, so 3.6 Newton along OC. See, again for the fourth one, so again it is a positive charge. So this positive charge will give a repulsive force. So FD also will act in the same direction of FB. Magnitude wise, anyhow, it is same. So 9 Newton. So now two forces FA and FC are acting along OC of magnitude 3.6 Newton, and FB and FD acting along OB of magnitude 9 Newton. So they will not nullify. So 9 Newton, two 9 Newton forces are acting in this direction, and two 3.6 Newton forces are acting in this direction. Now we have to find the resultant. Yes, so I have made all the calculations. So this is the last slide. Don't worry, this will get over. So 7.2 Newton FAC. So because they are in same direction means you can simply add. Similarly, FB plus FD, again they are in same direction. So you can add. So 18 Newton. So now two forces, 7.2 Newton along OC and 18 Newton along OB. So these are the two forces. Now they are making angle 90 degree, which you know, between those two vectors. So I am finding the resultant. So 90 degree, that's why I wrote only Rx squared plus Ry squared. You know the formula for 90 degree. So FBD squared plus FAC squared. So I found out, so the resultant magnitude is 19.38 Newton. And I've also found angle also. So tan inverse of Ry by Rx usually you do. So I'm taking this as Y component. So 7.2 by 18. So from the base, I'm taking 18 as base. So from 18 Newton vector at 21.8 degree, the resultant F net will be placed. See, I just wanted to give you a variety, the same exercise problem, but if values are changed and they ask in a different way how to approach, so for that reason only I've made the changes and I taught you. So usually if the two, so here the magnitudes are different, If the magnitudes are same, then the answer, final answer will come. So any guess? Angular bisector, so exactly will come in this direction. So there are problems like that also, but for this problem, so this is the answer. So I'm sure this will help you to understand the concept, students. CBSE is concerned, it is not only doing a particular problem. At the same time, you have to understand the concept also. If they change and ask also, you should be able to find the answer. So thank you. All the best, children. Thank you.